Hello, welcome to our April Infinite Recharge Live Online. We've got a couple of great teams with us this evening. We've all sort of more or less made it to the I don't know if it's the end of the season, but we've made it this far. Let's say that. And I've got a couple of students with us tonight, and we're going to be starting with Caleb from 12 Volt Bolt, and we're really glad he's here tonight. He's going to talk to us a little bit about the CAD projects that they've been working on and some tools they've refined. And we've also got, I'm going to pull her up here briefly. We've got Jolise from the Edgar Allan Ohms, and she'll be talking to you in a little bit about their innovation challenge. But we're going to go to Caleb first, and I'm going to let you talk a little bit about yourself and tell us about what you've been doing in the team, and then we'll pull your presentation up. So you want to introduce yourself and tell them a little bit about 12 Volt Bolt and where you are and what you've been doing.
Okay. I'm Caleb Bruner from 12 Volt. I've been on 12 Volt for 4 years now. 12 Volt is a community team based in Eustis, Florida.
Very
and,
nice.
Yeah.
Go ahead.
No, I don't.
All right. Well, I'm going to pull your presentation up here so you can tell us a little bit about what you're going to be sharing with us, and then I'm going to let you take it away.
So this year we came into a problem when we wanted to. Let me grab a. So here is this year's robot that we designed. It is nowhere near completion. It takes the ball up from the top here, or from the front, and shoots it out the back, with some balls and some wheels in the center to keep it organized. But we had an issue because we wanted to know where to place the piston, and we also didn't know how big the piston would be. Like we didn't know what throw it would have because we have several, or if we had to buy one. So we came up with this equation, which I've put over here on a little mini one. So with we decided we would take a look at just exactly how the piston would work, so we know exactly the arc. So because we'd have a point where it rotates and a point where the piston ends at, which we said would be horizontal. So from that, we placed a point there. So that means that the circle here is the rotation of the piston's axis. It's the location where the piston attaches to, and it'll rotate up and down with the motion of the robot. So along a throw of whatever number we wanted it to be, which happened to be this. Then we have the piston body, and that told us where the end point was, so we could put a point there and add our attachment mechanism. But the big thing is, we were using equations to drive everything. So normally you can access your equations and what is it? Tools, equations. And it'll bring up this menu here. And in this menu, you can change things. So you can make new sizes for. You can change a text number, and the model will automatically adapt. I forgot to prepare that number, but we took that equation and we noticed this down here, where we can link that equation to a text file. So instead of making an equation here and saying ball size, 7 inches, now we can go into any sketch and call that same equation equals ball size. We can set to 7, make sure it's using the equation. Now, whenever we change that equation, the ball size will change. So we can set the ball size is equal to 8. Now this circle up here will change. Now it's 8 digit, or it's 8 units across. But for all these units are unchangeable. That's because we linked them to the text file, which I can open here automatically, or I already have it open up here. And with this, we can change things directly from the text file. So here's my example cube. And I can, so you see we have it's 20 by 12 by 15, which we are. So now it's a 12 by 12 cube. So now I can change a distance. I'll change the height to be 20 inches high, save that. It'll automatically update. So this will allow us to, with the, what is it? Because we don't know what size our piston throw is, we can change it from a single text file that can be common to the entire robot. So if any unit on the robot needs to know how big the throw is, it will automatically change. Because you can share text files. They can share between the robot.
Brilliant. Had you done this before, or is this the first season you've tried this, or is this something a technique you've done before?
First time we tried this year.
Very nice. And where how did you all have CAD classes together, or is this something you were exploring and learned about and developed, or how did you get to this spot? This is great.
We learned about equations like late last year, and we didn't find a good way to use them. So we just played around them with ourselves in our own uses. And this year we put them to better use.
Right. That's really great. It looks like a tool you're going to be able to use a lot. That's
yeah. And so the last thing that's big was you can use it to, oh, hang on, it's on the other sketch. Right. You can use your equations to predict the side length of something. So here I have the sketch, which works naturally. You can just make the sketch with base units. But with the mounting integer, this can all just be done with geometry. So I can go to my piston file. So here I have the actual geometry of the equation. We're just taking in the throw and putting it into a Pythagorean theorem. So we have side A squared plus side B squared, square root of A, where you get the idea. So then we can square root it all, and that will automatically input the unknown dimension without doing it visually. So if we look in the equation, which it's updated in, the mounting size, now we have that number as a variable directly derived off of the previous dimensions. So with that, with our this year's robot, we were able to do gotta open up the folder. Robot equation. If I change the throw by a little bit, I can't change it too much, otherwise the entire model will break. Change it by 1 inch. Update it. This location will move. Give it a moment. I think it moved.
Very small amount, yes.
Yeah. Which can be like a big thing because it didn't just move this up and down. It also moved the side of the robot away from the edge. Do it again. This entire shape should move, I believe, this way. There it goes. Yeah. And that will automatically predict. So we can put any piston we find, we could use on this robot. And it will automatically move this bar to fit that location.
Nice. Yeah.
That's all I have.
Yeah, that's terrific. And if anybody has any questions, please put them in chat. So, the next natural question for me is, are you teaching any classes this summer? This would be really great. We did that last summer with the OHMs and any students that were interested. I think this would be really great.
Right. No, currently we're not teaching any classes.
I would highly encourage you to. It's a nice fundraiser. No, it could be, and this is a great tool. This is a really, really, really great resource, and you've really put it to good use. And I think it was a challenging year, but it was also a really interesting year to try out things that you don't normally get to do because you've got a little extra time to do it. And
it was a really great year for our team because we were able to really double down on our CAD and manufacturing.
Right. What did you do in respect with manufacturing?
Well, with the arm here, like last time I was on, I talked about some different materials and how we use our what is it? And I haven't grabbed them. Our 3D print models. That way, we can get highly accurate and custom shaped brackets like these without. Thank you, SolidWorks. Without using a CNC or router, like we can just make them in shop with our custom tools. This year we found a new material which we're using for our intake, which we have in real life.
Oh, wow. That's nice. And what is
which
that?
Which matches material. Yeah. I can't remember the name. We got it at a junkyard.
Okay.
But it's some poly material. It's it's similar to PETG, and that's clear.
Right.
But it's also quite dense. So it's and the big thing, I don't have it. It's somewhere in the shop. This material bends really nice.
Ooh. That's nice. It also looks pretty slick.
Yeah, the CAD model has wood on the robot. This one is a nice plastic.
Yeah. So, we see a lot of students, and ours included, sometimes CADing after they build. There seems to be obviously the best use of CAD is before you build, right? Or as you're building. Did you discover anything from your initial design, after you started CADing it that maybe came out completely different from what you expected? Significantly different, maybe.
Significant. Not too much. We were like the mechanical didn't start building until the CAD model was mostly done, so we didn't get a whole lot of changes, but we did because we spent a lot of time on the intake. But the we had to stop ourselves from tweaking anything because we made our nice equation, so everything's easily changeable. But we already cut pieces for it, so we can't change stuff, and that's really annoying.
That happens, yes. And how did you do? Were you able to do your robot skills challenges?
With the last robot, Miss Wendy hooked up a thing at UCF, and we just went there, I think, the other day, and we got to test out like 2 driving courses.
Nice, good. Well, congratulations. It's absolutely fantastic. Your CAD is exemplary. I'm sure that came in handy when you were doing your judged interviews. And that's another thing that I think teams don't often think of, is if you can have some really good CAD, it really makes for a really good conversation with the judges. And they can
very easy if you don't have a robot built yet.
Right, exactly. Well, that was absolutely fantastic. Don't go anywhere. We're going to pull Jaleesa up here and talk a little bit about the Innovation Challenge, and then we'll bring you both back on. But thank you very much for sharing that. I hope you will consider that summer fundraiser. I think you'd get a good turnout for doing CAD. I think everyone could really benefit. We actually did when we did the CAD for the team, when we opened it up to any other teams that wanted to participate. It turned out to be really, really helpful. And it's really something nice to do over the summer, and it really helps improve the skills. So, think about that. So let's bring Jaleesa up here. Hang on a second. And we'll bring Caleb back in a minute, a few minutes. So hello, Jaleesa. How are you doing? And you're on mute, so you have to unmute.
I'm doing good.
There you are, and you're on Team 5276, the Edgar Allan Ohms. You want to introduce yourself and tell a little bit about what you do on the team?
Okay, so my name is Jaleese. Typically, I do most of the creative stuff, so like crafts and arts. But most of the time, I'm really just like helping to build the robot, getting in a bit of programming lessons in between, and
You're new
just
this
pretty much a
season.
little bit of
Yeah,
everything.
right.
I'm new to everything.
She's new to everything. Yep. Actually, Jaleel, our first tech challenge team, and then got interested in the first robotics competition team, and took that one on as well. So, what have you found the most interesting on First Robotics? It's actually really different from FTC. So, what have you found the most interesting on First Robotics competition?
I mean, I feel like it's kind of cool how that. I mean, kind of just how they make the games,
Mm-hmm.
kind of how and the rules that go with it. It just makes it so much more interesting to play
Yeah.
because it's like, okay, you got this seems really simple, right? But here's this. It's like,
Yeah.
okay, we got to
Well,
think of it. We got to think of a way.
this was a challenging season to join any first team or any robotics team for the first time. So you've all done great. It's this isn't anything like seasons normally are, and everybody's done a great job making the best of it. And so you were helping out with the innovation challenge, right? On
Yeah.
Edgar Allan. Okay. Do you want to tell us a little bit about what you all came up with?
Okay, so we decided to try and make this like app. You can have it on your Oh, I just got a notification. Sorry, I don't know if you can hear that, but you can download it on laptop, tablets, or phones, any devices. Sorry, everything's happening. Okay.
Yeah, I see that.
Um, but you can download it on laptops, tablets, phones, any type of device really.
Hmm.
Um, it's mostly to aid occupational therapists to help them kind of communicate and work better with their patients, especially because of COVID and all this. Nobody really has the time to drive all the way to some place just to do one thing and then just drive all the way back home.
Hmm.
Nobody really wants to go that long way. So we decided to, well, we haven't really made it yet, but come up with this idea of an app that really we can send a message to the occupational therapist, and she kind of sets basically these daily tasks for the patient to do.
Hmm.
Um, and we more so focused on stroke victims. So, like people who have strokes, they parts of their bodies they lose most of their functions. So we kind of just decided, okay, they can download this app, and there's all these fun activities that you can do. You can play these games. There's a bunch of different options, and the occupational therapist will kind of just like set tasks for you, saying like you need to focus on this mainly for the day and stuff like that. So it's pretty much to just aid the occupational therapist, first of all, to make it easier for the occupational therapist
Hmm.
and the patient, um, and especially because of these times.
Right. There was also one you had worked on one component of that was a muscle sensor.
Yes.
Um, and because I know you were all playing around with the contacts for the arm, and what was do you remember what was behind that? What the project was there?
Um, so let me share my screen. Hold up. I have it pulled up. Let me just share my screen real quick.
Okay,
Okay. And
the share button's
okay.
down there at the bottom.
All right, here we go. Here we go. Okay. Can you see it?
In a second, it takes a minute to load up there. There you go. All right.
Okay. So the technology, we're using a muscle electromyography sensor that will be responsible for measuring the small, low frequency electrical potentials created by one's muscles. So it has a high impedance instrumentation. Amplifier will make the measurement via differential connection to various locations on the muscle, done using bare metal leads, using bare metal leads extending from the device. The amplified muscle signal will be integrated using a low-pass filter and rectified before it is sampled by an analog to dialogue converter for processing by the smartphone application or any other device.
So all that was to say that when you move your arm, it's going to send that information into the app, right?
Yes, so it's going
and the
to
degree of movement. Yeah.
Yeah. So it'll be located around, I don't know if you can see my, okay, around here.
Right.
So you kind of want it around there so it can really like sense the movements. And that's a better way to sense the movements.
Right.
Okay. Yeah.
Was there a VR component as well? Is somebody wearing a headset or something? I know there had been some discussion about that.
So I mean, we did have a discussion about that, but we decided not really to do it because we thought the sensors were really all we needed, because we only really needed to sense the movements and the pulse and how hard and how fast and everything that they're moving that limb of the body. So we decided using a headset wasn't really necessary for that if that was our main component.
Right. Nice. And who did you talk to? Did you talk to anybody when you were working on it? When you were all coming up with some ideas, or look at what was already out there?
We did get some insight from somebody. She was very helpful. We really did need some fresh eyes from somebody else because we were in a rough patch for a little bit. We were kind of stuck. But she did give us some pretty good insight, and that kind of got us to where we were, because other than that, we'd probably still be a little stuck.
It was a big challenge just to come up with some technology to address, physical or mental well-being. And that's a really broad topic, and there's a lot of things out there that people need. And then she talked about some things. I remember listening to her about you have to be careful because of HIPAA considerations, right? You can only give a certain amount of information because you have to protect patient privacy, which can make it difficult to get information. But that's going to be great. So you guys have your Innovation Challenge interview tomorrow, I think, right?
Yes.
Yeah, you do. Yeah. And what did you find interesting about that? I mean, have you played with the muscle? I know we got a muscle sensor, and a couple of students were working with it last week.
I have not personally played with it, but I have seen Chase playing around with it a couple times. But yeah, it works pretty well. I haven't I haven't really personally checked it out though.
Right. And now did you do any, what else did you work on? Were you on with the game design too, or what other projects did you work on with the team this season?
No, I mean we pretty much we set ourselves into groups. So we kind of split up the team into what needed to be done. So we split up into 3 parts. One part was working on game design ideas. The other part was another part was working on innovation, and then a little group of people were working on the robot at a time, so we could kind of get that efficiency and kind of get everything to have a bit more progress over the way.
Yeah, it looks like everybody got to do something on there. So you were all using all the different tools. I saw you using some tools I don't usually see you on. So pretty cool.
So we would discuss for an hour about an hour every Saturday. And then we'd all come back together and we'd present our ideas, and then the opposite team, including the people that were working on the robot, would give conductive feedback on how we can elaborate on that and make it better.
Right. And
kind of make it more effective.
Right. Very good. And I don't know if Caleb's still around there. I'll pull him back up, and I'd like to hear what you there, Caleb? There you are. And so what were some of the other, did you all do the Innovation Challenge in game design as well?
Sorry? What was
I
the
said,
que-
did you all work on the innovation challenge and game design challenges as well?
We attempted to do the game design challenge, but we
Uh-huh.
found we just didn't have enough resources to spend on it.
Yeah, that
Or
was
any. We wanted to stay pretty focused on the robot, which we
Yeah.
still didn't finish.
yeah. So the challenges of meeting. Did you all have a meeting place for the season, or how did you all handle that?
Yeah, it's some 30
garage.
feet that way in my garage.
So that's gonna be a challenge. Yeah, not
Yeah.
having you know. And
Which
your
you could have seen in the virtual pit tour if you were there with Miss Wendy.
Oh, that's right. I wasn't on there. I think some of our students might have been on it. That's very cool. Very, very cool. So what did you find the most interesting this season, Caleb?
Of the season? Definitely
Yeah,
tough question. There are a lot of interesting things that our team did.
right.
Okay, the not having a competition, so not having a goal was rather difficult. Because we had to
Yeah.
make that ourselves a little bit. Like there's the challenge, but it's still difficult to complete, especially since there's not such a competition. It's just a time.
Yeah. Yeah. Not having that goal, you have to have a robot done by this date for your competition, and you're going to do these things. And so there's hang a second. We'll pop that up. Whoops, it's not going up there. Yeah. Technology is interesting.
Maybe I need to stop sharing my screen.
No, it's okay. It should be all right. There we go. Working in the rain. And direct sun. So those are interesting challenges when you're working in a home garage.
Yeah.
I like your garage mascot that keeps running out of the garage too. That's pretty cool.
Yeah.
Yeah. And have you been on the team before, or was this is your second year, Caleb, or how long have you been on the team?
This is my 4th year on the team, with one more to go.
4th year on the team. Okay, so yeah, so you've got something to compare with. Jaleese has nothing to compare with, right? And all new students who join teams, and this is when you imagine this is your introduction to the season, and
yeah, it's
there's
we've had some fresh members.
It's
a constant reminder because when we got to go to UCF and it was like giant and empty, and like we had to explain to the new members like this is supposed to be full of people, like cheering. It's like they don't get it at all, like how large it is. Miss Terry, I believe you froze. You at least did for me.
Yeah, I'm having my connections dropping out over here.
But
yeah, it's such a different it is such a different experience to do this. Even the deadlines for the things like the innovation challenge and robot, it's not the same as like you have to be done and over and loaded into your pit.
Yeah.
It's completely. I'm hoping that will hang in and we'll have a season. We are hoping to have a at Rock, so hopefully we can give us somewhat of an chance to be a group of and
sorry, you're quite a bit choppy.
I know.
My team is very excited. If
course,
come back to. Okay, I think you freshened up.
Yeah.
Yeah.
I'm gonna drop out. You two talk amongst your. Yeah. Hang on a second.
Hi, puppies. Come here, Judy. Come on. For the camera. Yeah. This is Juniper, and over there is Jasper, who's the team safety dog.
Oh, they're so cute. They're so adorable.
For the camera, Judy. Okay.
He said, I want to be free.
Yeah.
Okay, that should be better. For whatever
Yeah, that's
reason, my Wi-Fi starts to drop out, and so bringing a dog on the screen is always a really good time filler.
Yeah.
Quick, look at the dog while the host goes and finds a better connection. So yes, I started to say we're really looking forward to having a scrimmage here.
Yeah.
And it looks like we've got 2 or 3 other teams interested, so we should actually have a nice full field here. We have to come up with some new games to make it more fun, and
Right.
see what we can do with a bunch of randomly built robots to shoot dodgeballs. So
Yeah.
I think that'll be fun. We'll come up with something.
12 volts looking forward to the next Rocket League event.
Yeah. So I think it's been great. I appreciate both of you coming on. Obviously, it's going to be a short show, but we just want to stay connected with everybody and keep having conversations. You can hear noise in the background. The First Tech Challenge team is here. I don't know if you can hear them, but they're practicing their driving for their remote challenges tomorrow. I did kind of like the way First Tech Challenge did it, where they ran, the matches throughout the season for a week. So you would have a week to run your matches, record them, and then you could record them if you wanted to, but then submit them on the live scoring. And that was kind of fun. I think that was a kind of made up for a lot of the challenges of the season. But we'll keep going, and next season will be even more fun. Hopefully we won't have to pay infinite recharge another year.
Yeah.
Come up with something new. It's like the Groundhog Day of games.
Yeah, I'm really looking forward to a new game. Although this one taught us a lot about fixing our old design.
Yeah, and I think that can be said of this season, right? Everybody was sort of, at least if you approach the season with some energy behind it, the things that you could learn to try out that you wouldn't ordinarily maybe necessarily have the time to try out for a competition season. If you can take all the stuff you learned this season, and apply it for an actual competition season, I think that can make for some stronger teams and some stronger competitors. What's the one thing you want to take away from this season, do you think, Caleb?
To keep working. There's always room to make new stuff. Like we kept working in our garage because the previous year we had lost our building, and we're still making robots.
Yeah, good job, and you're making nice ones too. It's beautiful. Yeah. That's great. So we're really excited about that. And Jaleese, you're gonna hang out. You're gonna hang in there for more seasons, right? You're gonna stay involved.
Yes, very much.
All right. So you've been trying out all sorts of different things on the team. You originally came onto the FTC team because you thought it was a cool name, and you made some cool stuff for us out of duct tape. And the next thing you know, you're learning programming and a little bit of computer-aided design, and you're, bolting things together. What have you enjoyed that you didn't expect to experience or expect to find that you've liked that you've never done before? Was there anything in particular you really liked?
I mean, I don't know, pretty much everything, because I'm not really a robotics person. I'm a crafts and arts person. And then my dad just said, okay, you're going into this robotics thing. And I was like, oh, okay.
To be fair, her brothers are on the team too. So
I've done a coding class. I've done a coding class before. Never been on a robotics team. So I was like, oh, okay. I came on here. I was like, oh, I'm having a lot of fun. And then I helped out Team Edgar Allan Knows, and Terry was like, you want to join them? I was like, oh, sure. I helped out Team Bex. She's like, you want to join? I was like, oh, sure. And now I'm on 3 teams.
Yeah. But the artistic portion of it is important, right? I mean, even whenever I look at that computer-aided drafting, the design stuff you did, it's beautiful. There's a lot of art to that. And
there's also fun branding stuff. Like a couple years back, we got a facelift on our team logo.
Oh yeah, I like that. Yeah. That's great.
Which our team is super thrilled about, and we have a giant flag that we got printed.
Nice. And we've been talking about that, refreshing logos. I think we recently had a conversation on that, didn't we, Jaleese, about freshening some things up. And it's good to do. Teams get really attached to their logos and designs, but as you move along, sometimes it's time to update, and clean up those websites and come up with some new ways to get attention, and so that artistic portion is really important. That's what helps your team stand out. So, but I think that's fantastic, and we're going to have her coding pretty soon anyway. So, But thank you both so much. What's that?
We'll see how that goes.
Oh, it'll go well. It'll go wonderfully. You know, you can teach everybody else how to use the Cricut because she does some really cool stuff on those designs on the Cricut, and that's pretty handy. Yeah, that we need that a lot. But thank you both so much for coming on this evening. We really appreciate it. Next week, in a couple of weeks on the 23rd, I believe, is our last Infinite Recharge Live. And we'll have a couple more teams on. I think we'll have Royal Robotics. I don't know who the other one is, but if anybody wants to come back on from your teams and chat, we'd love to have you. Find out some other cool things you've all done. I'd like to see, hopefully we'll have the swerve drive running on Ohm's robot and we can demonstrate that here. That would be a lot of fun to do.
Yeah. Our team, we would love to see that because our team is considering doing a practice swerve bot.
Yeah, that turned out to be challenging. So it was a challenging build, and one of the motor controllers didn't work properly. So it's like right before you're turning in the videos. So it's like, all right, we'll make it work. So it would really nice to see robots in action. So maybe we'll just do a robots in action event next time, and people can even just send us videos if they can't be on. So that could be a lot of fun to just show those and then talk about them. So if you've got some videos of your robot, send them along, and we'll invite others to do it, and we'll do a video showcase montage.
That'd be fun.
Yeah, I think so too. So thank you again, both of you very much. Come back on April 23rd for our last Infinite Recharge Live, and stay tuned for news about our upcoming scrimmage for any teams in the area who might like to come and play on the field and connect with other folks. We're really looking forward to having everybody, and enjoy your evenings. And the dog is really adorable. So
hang on. Oh, there are treats on the couch.
Aha, not anymore. Yeah. That's awesome. Well, thank you again, 12-volt Bolt and Edgar Allan Ohms. We will see you all out there in robot land later on. All right.
Thank you very much.
Have a great evening.